PLC, in simple terms, modulates the communication signals and sends this over existing power lines. Now, this is great because it allows devices to be connected without the need for any new cables or wires. It's extremely attractive because it allows simple devices to become intelligent through the use of networking. Now, I want you to imagine for a second if everyone in this room started talking at the same time. You can see how it'd be hard for two people to communicate. And that's exactly the problem with PLCs today, is that they tend to operate on the same frequency or the same tone mask. And this causes a lot of interference. So our solution to this problem is to implement a MAC protocol that acts as a border node between two networks. So if I can direct your attention to the picture in the middle, you see our smart meter sits between a utility network and a home area network. Now the smart meter is able to talk on two different frequencies, whereas the home area network and the utility grid are separate, or isolated on different frequencies, and this solves the issue of noise, of any crosstalk. Now how the smart meter talks is, if you look at the superframe structure, it sends out beacons on all the different frequencies and waits for an acknowledge message to come back. And once it receives this, it then assigns transmission regions to each of the networks. Now how the individual networks know when to talk and when to listen is through the beacon itself. If you look at the beacon frame structure, you see it consists of the upper MAC header, the beacon payload, as well as the footer. And inside the inside the beacon payload, there's a cap 1 and a cap 2 duration. This is what lets the individual networks know when to communicate. Now the superframe structure has a period of 1 second. And how we assign the different transmit times to each individual network is by first computing the time it takes to send and receive the beacon frame. We've done this using the formula to your right. And we've computed this to be approximately 30 milliseconds. And so depending on this, we then assigned the rest of the time to transmit data between the two networks. So for our Senior Design 1 for this semester, we've also completed implementing most of the HCT messages, which lets the board communicate with each other. And our plans for the future is to fully implement the HCT messages and have the boards communicating on two different frequencies. And also to set up a demo where information is received from the utility grid and is displayed on a screen in the home area network by the help of the Simplified. And so our hope is that this project helps better people's lives by making everyday objects around them smart. Are there any questions?
Does the protocol include transmission in the case of failure, and if so, exactly the problem during the scheduling and timing?
It is failure. We're gonna start the superframe structure again.
If failure.
Yes. If the beacon for either frequency is failing, then we're gonna start the superframe again.
And the superframe defines how different users, in terms of their timing, access a channel?
Yes. For example, this is the low frequency band. This is gonna be used for the home device to access the information, what time it needs to wake up to talk to the smart meter, and then what time it needs to go to sleep and wait for the communication between the smart meter and the data grid to communicate. So this is the way we actually switch frequency time sharing manner in order to talk between devices.
This is an age-old problem. Usually